Welcome to day one. Homework will be packet page 7 and 8. You should have a new packet that was passed out to you. We are going to need calculators today, and we'll start out on page 1. So we'll give you 30 seconds to have those two things out, calculators out and packet page 1 out. So this unit is going to be working with circles. Our focus on this unit will be angles within circles, and then our next unit will be working with segments that are drawn within circles. So on page 1, first off, a central angle is an angle whose vertex is at the center of the circle. And I'll draw you a little picture of a central angle here. So here's the center of our circle. So there is a vertex that's happening at the center. So the central angle we're talking about is that angle right there. So the angle, the vertex is at the center, and the angle opens up towards a portion of the circle. The circumference is the distance around the outside of the circle. Think of circumference as like perimeter for a circle. So in the picture I just drew here, it would be this part is our circumference. And there's two formulas for circumference. They are on your reference sheet on the Regents. You have circumference equals 2 pi times radius. And because twice the radius is just the diameter, you could also think of it as circumference equals pi times diameter. Now just an aside for a second of what pi really is. In that second formula, notice if you wanted to get pi by itself, you would just divide both sides by d. So circumference divided by diameter is pi. And that's what pi is. If you took any perfect circle, measured the circumference, and then measured the diameter, it would always come out to be pi. And that's where pi comes from. Now just radius and diameter to make sure we're solid with those. So your center to any point on the circle, that's your radius. And in a circle, any segment that goes through the center and has endpoints on the circle, that would be a diameter. And the diameter is always twice the length of the radius. And our last fill in the blank there, an arc is a section of the circumference of the circle. In our picture on the top left, an example of an arc would be like this. Think of the arc as like the crust of a slice of pizza. So today's lesson, we're going to focus on sectors in a circle. A sector, think of it as a slice of pizza or a slice of pie out of the circle. So this thing here, that's our sector. With that sector, we're going to work with two things. We're going to work with the arc length, which is like the crust of the slice of pizza. And we'll work with the area of that sector, which think of it as how much like pie or pizza you actually get. So first we're going to work with arc length. So to work with arc length, we're just going to set up a proportion. We're going to put the parts on top and the holes on the bottom. So first off, the central angles variable, you'll often see theta. Theta you draw, you kind of do a circle, and then you loop back through the middle. So that's our theta. It's a Greek letter. And it is the variable that back in old ancient times they would use to represent an angle measure, and it's just continued on the tradition. So that top left is always going to be our central angle, which will be the variable theta. The central angle represents part of the angle of an entire circle. On the bottom, at this center here, imagine how many degrees it is all the way around the center of that circle. If you go all the way around, it would be 360 degrees. So on the bottom of that fraction, we will always have 360. The central angle amount will change from problem to problem, but the bottom left will always be 360. And so what we have on the left is we have a partial over a whole. The partial angle over the whole angle. On the right, we're going to again do a part over a whole. Now we want to find in this setup the arc length, which is the crust of a slice of pizza. So that's part of the whole circumference, so that's going to go on top of the other fraction. So we'll have arc length, and we'll often use a capital L to abbreviate that. Well, the arc length is the part of what thing? The arc length is part of the entire circumference, so on the bottom of that fraction we will have circumference. So the tops are parts, the bottoms are wholes. Now a shorthand way of writing this, which you can put in the box on the bottom, we got theta over 360 degrees. Theta, again, is the central angle, equals L, our arc length. And then you can replace circumference with one of the circumference formulas, either pi times d or 2 pi r. I'm going to, in the notes, use 2 pi r, but if you wanted to use pi d, that's perfectly fine. But you'll see me using 2 pi r as we do the video. All right, so let's go to the next page and see if we can practice that proportion. So given the radius r of a circle, find the length of the arc intercepted by the central angle. So in the question, we want to focus on the fact that they want us to find the length of the arc, or in other words, the arc length. So the connection we want to make is, oh, we're just going to use the proportion that we saw on the previous page. So we're going to have theta, our central angle, over 360 equals our arc length over 2 pi r, which is the circumference. Well, notice they tell us theta. Theta is 45 degrees over 360 equals, our arc length is what we're looking to find in the question. So we're going to leave that as L. And then we'll have 2 pi times what they told us our radius was, 16. And now to find L, we're just going to cross multiply. So 360 times L will just give us 360L. And this is where our calculators are going to come into play. We're going to do 45 times 2 pi times 16. But notice it does not say we're rounding anywhere in the question. So kind of like when we did our volume and surface area units, if it didn't tell us to round, we're going to leave it in exact form. Meaning we're just going to tack the pi on the end. So when we put this in the calculator, we're not going to type the pi in, we'll just put it after our answer. So in our calculator, we're just going to do 45 times 2 times 16. So again, do just the 45 times 2 times 16. And we should find that's 1,440 pi. We can divide both sides by 360 to get L by itself. So L is going to equal, when we go to divide the right side, only the numerator has a pi, so our answer is going to have a pi in it. When we put it in the calculator, we're just going to do the 1440 divided by 360. So go ahead, put that in the calculator. And we should have gotten 4. So our arc length is 4 pi. Now just a visual of what we found. So here's roughly something with a 45-degree angle. We have a radius of 16 centimeters. So we just found this length here, this arc length. Well, it's a distance, so its units should be a distant unit. The distance unit of your arc length will always match the distance unit of your radius. So our units for this one is going to be 4 pi centimeters. So we got another example here. We're going to do now, what if we wanted to find the arc length when the radius is 10 and the central angle theta is 90? So we're just going to do 90 over 360 equals, we're looking for the arc length, so we'll leave that as L, 2 pi times a radius of 10 this time. We're going to cross multiply. That way will give us 360L again. Cross multiply going the other way. It doesn't tell us to round it all, so we're going to have our answer in terms of pi. So when you put it in the calculator, just do 90 times 2 times 10, and then we'll put the pi at the end afterwards. And we should get 1800 pi. To get L by itself, we want to undo the fact that it's being multiplied by 360. So we'll divide both sides by 360. There's only a pi in the numerator, so our answer will have a pi in it. When we put it in the calculator, we'll just do 1800 divided by 360. And when we do that, we should get 5. Arc length is a length, a distance, so its unit should be a distance unit. It'll match the distance unit of the radius, so we get 5 pi inches. So that is one proportion we're going to work with today, the arc length proportion. If we go down to the bottom, we're also going to work with the area of a sector. A sector, again, is a slice of pie or a slice of pizza. The area of the sector is all this space here. Well, we're going to, again, do a proportion with parts over wholes. Top left is exactly identical to the other one. We're going to have the central angle. Central angle is our theta. And just so you can see the spelling of that, that's T-H-E-T-A. So that Greek letter theta is just the variable for our angle. And it'll be over 360 degrees. So notice the left side of this proportion, exactly identical to the left side of our arc length proportion. But the right side is where it's going to be different. Because on the top right, where we had arc length before, which was like the crust of the piece of pizza, this time we want the area of the sector. So the area of our sector, I'm just going to call it A with S as a subscript for the area of just the sector. And then the bottom would be the whole thing, which would be the area of the circle. So I'll call that with A with a C as a subscript, just to differentiate between them for now, because we have A's on both. When we're solving, we'll only be solving for one of the two things. And a way to simplify that, area of a circle is just pi r squared, and that's on your reference sheet on the Regents. So we just have theta over 360, and our area of our sector over pi times radius squared. So if it's talking about area of a sector, we should be using this proportion. It's again just a parts on top and the wholes on the bottom. Going over to the next page, we're given a radius and a central angle. We want to find the area of the sector. So because we want to find the area of the sector, that should tell us we want to use the proportion theta over 360 equals the area of our sector over pi r squared. Now I'm not going to put S on that area of the sector just because we only have that one left to find. We've already replaced the bottom right with pi r squared, so we don't have to differentiate between them. Once you know your proportion, we're just filling stuff in and cross multiplying, so it's not too much different than the other ones. So theta's 50, so I have 50 over 360 equals our area of the sector we don't know, and we'll have pi times 6 squared. We're going to cross multiply, so going this way we have 360a. Going the other way, we have 50 times pi times 6 squared. So it does not say to round, so we're going to keep this in terms of pi. So we'll have the pi at the end. And on your calculator, you're just going to do the 50 times 6 squared. And we'll give you a moment to do that on your calculator. And we should get 1800 for that. We are trying to get a by itself, so the opposite of multiplying by 360 is dividing by 360. We're going to have pi in our answer because there's just pi in the numerator, so we just have to divide the 1800 by 360. And when we do that, we should get 5. So we're going to have 5 pi. But we got to think about units here. This answer is an area. When you have an area, your units should be some units squared. So in this case, we're going to have inches squared because our radius units were inches. Now I want to point out one thing you can do with these problems, either of these proportions, if you want. If you ever have a fraction on one side that's just numbers, so like this was 50 over 360, you are welcome to reduce that first if you want before cross multiplying. If we had typed in 50 over 360 to reduce it, you would have gotten 5 over 36. So you could have then rewrote the proportion and then multiplied with and done it with the reduced fraction. You are welcome to do that if you would like, if you want to work with some smaller numbers. Again, you can do that reducing if one of the fractions has only numbers in it. If we had a variable in the fraction, like the a, for example, we wouldn't be able to do it on the right side. All right, another example, same thing. Finding the area of the sector. We've got our theta is 120 over 360 equals our area of the sector that we don't know, and then pi times 9 squared. So take a minute or two, see if you can cross multiply and solve this. It doesn't say to round, so we would want in terms of pi for our answer, and think about what your unit should be once you get that answer. So we should have got 27 pi. It's an area, so we should have our units squared. The radius is units. We're meters here, so we should have meters squared as our units. So the big decision at the start of the problem for these is which proportion should we use? If it's area of the sector, over on the right side we'll have a over pi r squared. And if you determine its arc length, on the right side of the proportion you'll have L over 2 pi r. And that's the big decision. Once you have that decided, we're just filling in what we know and cross multiplying to find what we don't know. So if we go down to the bottom of page 3, the area of the sector of a circle with radius 8 is 16 pi. Find the measure of the central angle that forms the sector. So we always want to be on the lookout for, are they talking about arc length or area of the sector? And it comes right out and tells us area of the sector. So when we recognize that, write out your proportion, theta over 360. It's area, so we want the one with the A, over the area of the circle formula, which is pi r squared. So knowing those, which one to use, is really the task in this problem. Once you have that down, these are pretty easy. Now, something to note in this problem, we're finding something different. We want to find the measure of the central angle. So the theta is what we will not be subbing in for here. So we're going to have theta over 360. Now, when theta doesn't get subbed in for, I like to purposely make my line in the middle go a little extra, just because that helps me recognize, oh, that's not really a 0. The technical theta, it just kind of goes right in the middle like that. Kind of looks like the Pepsi symbol almost. But I like to purposely extend it a little bit just so I don't accidentally confuse it for a 0. You are also welcome to put some other variable in for theta if you wanted like an x. That's fine as well. On the top right should be the area of the sector. They told us that area of the sector is 16 pi. And then we've got pi times 8 squared. So we're going to cross multiply. 8 times 8 is 64. So we're going to have 64 pi theta equals, when we multiply the other way, we're just going to have something in terms of pi. So we just have to do the 360 times 16, which should give us 5,760. Keep in mind, pi is a number. It is not a variable. The variable we're trying to find here is theta. So to get theta by itself, we've got to divide by 64 pi. So on the left, we'll just have theta. Now on the right, notice we have a pi in the numerator and a pi in the denominator. Well, if you had 7 divided by 7, that's 1. If you had 6 divided by 6, that's 1. So if you have pi divided by pi, that's also 1. So the pi's essentially divide each other out, and it'll be a 1, so that's not going to factor in our answer. So we can just do the 5760 divided by 64. We'll give you a moment to put that in. And that should give us 90. And we got to decide what our label is on that. Well, theta was an angle, the central angle. Our label on angles are degrees. Now, one alternative of how you could have done this, in the beginning, if you had noticed that you have a pi in the numerator and a pi in the denominator, you can divide those pi's out right then and then cross multiply without the pi's. Or you can just wait to divide them out later on when you do your divide by 64 pi. All right, flipping over to page 4. Take a moment to read the problem, and we want to be hunting for, are they talking about area of a sector, or are they talking about arc length? Hopefully we recognize area of the sector. Both have theta over 360 on the left. If we're doing area of a sector, we should have area stuff on the right. So A on top, and area of a circle is pi r squared. Now here's just a little thing to help remember which one should be pi r squared, which one should be 2 pi r. If you recognize you're dealing with area, think about how area's units are always units squared. So that can help remind you that we would want the one with a squared here if we're dealing with area. The thing we want to find is the central angle. So we won't have anything for theta. Our area of a sector, they told us, was 6 pi feet squared. And we'll have pi times our radius squared, so pi times 4 squared. If we go ahead and cross multiply, 4 times 4 is 16. So we're going to have 16 pi theta equals, we'll have some number of pi. We'll give you a moment to cross multiply that other one. So we should get 2160. Pi is a number, not a variable. So the variable we're solving for is theta. So we'll divide the 16 pi out of there because opposite of multiplying is dividing. And we'll end up with theta equals, the pi's divide each other out. And so we just got to do the 2160 divided by 16. And we should get 135. And it's an angle, so that's degrees. Again, if you wanted, in the beginning here, you could have divided the pi's out right there, and then done the cross multiplying without the pi's. You'd end up with the same thing. All right, going down to the bottom, read our question, and we're hunting for, are they talking about arc length, or are they talking about area of the sector? Hopefully we recognize they're talking about area of a sector. So it's just like the last three, theta over 360 equals area of the sector over pi r squared. And notice we're finding the measure of the central angle. So exactly the same as what we were just been doing. So we'll keep letting the video run, but see if you can take 2 minutes to solve this. All right, we should have ended up with 72 degrees in the long run. Theta over 360 equals 5 pi over pi times 5 squared. Cross multiply. Don't forget your degrees on your answer. All right, last two for today over on page 5. Or I take that back. We'll have 3. We have one more on page 6 when we get there. So in 6, we're dealing with area of a sector again. So we know we're doing theta over 360 equals area over pi r squared, area of the sector. This time they want us to find the radius though. So we should be able to fill in for everything except for r. Central angle is 36 over 360 equals, they tell us the area of the sector is 20 pi, and then we don't know the radius, so we'll leave this as pi r squared. We'll cross multiply, we'll get 36 pi r squared equals, when we cross multiply the other way, we're just going to be tacking the pi on the end. So multiply the numbers out, we get 7,200 pi. We're going to divide both sides by 36 pi. And this will give us r squared equals 200. Well, the opposite of squaring something is taking the square root. So we're going to end up with r equals square root of 200. So first, on your calculator, just do square root of 200. See, does it come out nice? So we'll give you 15 seconds. See if you can do square root of 200. See if it comes out nice. You should have found out that it does not come out nice. So we'd want to do a menu number factor. When you do menu number factor, just put the number under the square root in. So go ahead, do menu number factor and do your 200. And we should have gotten 2 times 2 times 2 times 5 times 5. We got a pair of 2's and a pair of 5's. So this would equal 2 times 5 out front with a square root of 2 still inside. Or in other words, 10 square root of 2 for our radius. A radius is a distance measurement. So our units would be whatever they told us in the question, but they didn't tell us any units, so we can't label it. So we'll just have 10 square root of 2. Moving down to the bottom, read the question, hunt to see if they are talking about arc length or area of the sector. Hopefully you recognize arc length. So we'll have theta over 360, that's always the same. But now that we have arc length, we're going to have the L over 2 pi r that we started the video with. Arc length is what we're trying to find, so the L is what we're not going to know. Theta was 72, and we'll have 2 pi times 5 in the bottom right. Cross multiplying, we'll have 360L equals, other way will be some amount of pi, so we're just going to do the 72 times the 2 times the 5, which that'll give us 720. L is what we're solving for, so we'll divide both sides by 360. There's only pi on the top, so our answer will have pi in it. And 720 divided by 360 will give us 2 pi. Arc length is a distance measurement, so our unit should be a distance, which in this problem we are working with centimeters. Last one for this video over on page 6. They come out right away in the beginning, tell us we're working with arc length. So we've got theta over 360 equals L over 2 pi r. And we're trying to find the radius. So we should be able to fill in for everything except for the r. Angle was 72. The arc length, they told us, is 4 pi. And we'll have over 2 pi r. You can either divide the pi's out now or wait till later on. I'll wait till later on, I guess. When you do the 2 pi times the 72, that'll give us 144 pi r. When we do the 360 times the 4, we'll get 1440, and we'll tack the pi on. Divide both sides by 144 pi. So that's all gone. We'll have r equals, pi's will divide out, so we're just doing 1440 divided by 144, and we should get radius is 10. It's a distance measurement, but notice they did not give us a units for the arc length, so we don't have any units that we can put on this one. So read the question, decide which proportion, fill in what you know, cross multiply to solve for the thing we don't know, put units on if you had units in the problem. Any time left in the period, you can work on the homework. Have a great rest of your day.